Hello everyone, welcome back to another video on function, further example. So in this further example, in the first page, to check if whether it is a function or not, we have a vertical line test. So in the vertical line test, which means that if we move over the x value, interacts the graph, you will only have exactly one and and every time you only have one value of y. So which means that if you have one x, if you draw a vertical line, okay, so you will always see that it will only touch the graph once. So in this first graph here, this is a function, because every time when you draw a vertical line, and you only have one intersection, one value, or one outcome. So one object, one image, one object, one image. Okay. Then we go to the next example, example number 2. Okay. Does this graph represent a function? So if you draw a vertical line, and you will notice that there is actually 2 points of intersection. The vertical line cuts the curve at 2 places. So we have, then therefore we will say that this graph is actually not a function. So that is the vertical line test to determine whether the graph is a function or not. So we just draw a vertical line. So let's move on to the miscellaneous example. So in miscellaneous example, you have function p, p of x is equals to x plus 3. And you have an arrow diagram there, and you are asked to find a, b, and c. So you are given p maps x onto x plus 3. Right? We can rewrite this as p of x equals to x plus 3. So in order to find this value of a, b, c, we need to use this arrow diagram to find. So let's start with the first one. So looking at that arrow diagram, so that is x equals to 5, which means that p of 5 is actually equals to a. P of 5 means your x become 5, so which means that x plus 3 is actually 5 plus 3 equals to a. So from there, we can say that a is actually equals to 8. Then let's look into the second one. The second one, which we have looking at it, we are looking at this part. Object b is mapped onto 10. So which means that pb is equals to 10. PB means your x actually substitute that become b. So x plus 3 become b plus 3 equals to 10. So plus 3 bring over become minus. So 10 minus 3, therefore b is 7. Then looking at the last, the last condition here, the last arrow, that will say that p of c is actually equals to 4c. When x is c, you have the range 4c, the image 4c. So p of c means your x become c. Therefore, x plus 3 become c plus 3 is equals to 4c. Since both of them having c, so let's move it into one side, collect all the likes term together. So you have 3 equals to 4c minus c. Because this is a positive. 4c minus c gives you 3c equals to 3. Then bring 3 to the left, become divide. Therefore, we can say that c is actually equals to 1. Alright, so therefore you have your value for a, b, and c. Then part b, what type of function is this? If you look at the arrow, all the object has one image. Therefore, from part b, we can say this is a one-to-one function. Then let's move on to the second miscellaneous example. Okay, second miscellaneous example, we have function h, right? H of x is equals to 3x squared plus ax minus 1. Okay, and you are given the condition h of 3 is equals to 8, and you are asked to find the value of a. Okay, so these are the condition given. So in order to find the value of a, let's use this condition. Okay, h of 3 is equals to 8, which means that h of 3 means your x become 3. So from there, you will have 3 bracket 3 square. Okay, we are changing the x become 3. Then plus a times 3 minus 1, and everything is equals to 8. Alright, then from there, let's simplify that. So 3 square means 3 times 3, which is 9. 9 times 3 is 27. Plus a times 3 is 3a minus 1 equals to 8. Okay, 27 minus 1 gives you 26 plus 3a equals to 8. Okay, so we are asked to find a, so let's move 26 to the other side. So we have 3a is equals to 8 minus 26. Okay, so from there, 8 minus 26 will give you negative 18. Okay, then move the 3 to the other side. Therefore, a will be negative 18 over 3. So answer will be a negative 6. Okay, so that is for example 2. Let's move on to the third example. Third example, a function g is defined by g of p is equals to p squared plus 2p. Okay, solve gp equals to 3. Okay, so you are given the condition gp is equals to 3. Okay, so what's gonna happen will be, we know what is gp. Gp is actually p squared plus 2p. So we change gp become p squared plus 2p, which is equals to 3. Okay, since you are asked to solve, so let's make it equal to 0. Move the 3 to the left, so you have p squared plus 2p minus 3 equals to 0. Okay, so that is a quadratic, so you can factorize it. Okay, so first column p squared, second column negative 3, third column a positive 2p. So we know p times p gives me p squared. Okay, and then we will know that 3 times negative 1 gives you negative 3. Cross multiply, p times 3 is 3p. P times negative 1 is negative p. Okay, we always have to plus them. So 3 plus a negative 1 gives you positive 2. Okay, which is correct. Then let's rewrite the factor. So we will have p plus 3. Okay, that's one bracket. Okay, writing it across, and second bracket will be p minus 1 equals to 0. So from there, we will know that p plus 3 is actually equals to 0, or p minus 1 is actually equals to 0. So move plus 3 to the other side, so p is actually equals to minus 3. Okay, because 0 minus 3. Move minus 1 to the other side, become plus 1, and 0 plus 1 gives you 1. So therefore, your answer will be p equals to negative 3 and p equals to 1. Okay, so that's it for this video, okay, on the further example notes. All right, so see you around in the next video. Okay, bye bye.